Hi everyone, and welcome to today's Physics Daily Booster. This is number 16 in our series. While this isn't a topic that is explicitly listed on the advanced information, that doesn't mean there won't be questions on it, as we've already seen from the earlier paper. What we're looking at today then is the idea of fields. So we're going to be starting to get our hands out in a sensible way in the exams. Now, you do need, for this little section of physics, to be able to use your hands in order to work out certain directions of things. Do this subtly. Obviously, don't be waving your arms massively around the room so that the invigilators think that you're flagging down other people in the sort of actually the exam hall. But if you're just doing this on your desk, then it's absolutely fine. What we're going to look at then is, first of all, when a current flows through a wire. So as soon as that current flows through the wire, then we have a magnetic field around it. That single wire is going to have a series of concentric circles as the shape of the magnetic field. Concentric circles just means circles sitting one inside the other. If they ask you to draw the field lines around a single piece of wire, it would just be at least 2 to 3 circles, just one sitting inside the other. And then you need the direction, the arrowheads on it. So this is where you get your right hand and give yourself a little thumbs up at this point. So your thumb has got to point in the direction the current flows through the wire. It will show you that on the diagram. Then look at the direction your fingers are curling. That's the direction you put the arrowhead on. What we can do to actually prove that what I've just said is true is we can carry out one of 2 experiments. The first experiment involves just using some iron filings. So you pass your bit of wire through a single sheet of card. You're then going to make sure that's connected onto a cell and a switch. And what we're going to do is turn on our little circuit and then shake iron filings around the card. They will line up to show the field lines. Option 2 is we still have our wire connected into a circuit of a cell and a switch, still got our bit of card, but this time we're going to place a little plotting compass right next to the wire. Turn it on. Where the little compass lines up, you then put a little mark on the card. Then you're going to move it sort of tip to tail and then mark that again, and then you can plot the field lines in that regard. What we find then is we can actually see different magnetic field strengths with our current carrying wire. 2 things are going to affect this magnetic field strength. Firstly, the magnitude or the size of the current. So the bigger the current, the stronger the magnetic field will be. Secondly, the distance from the wire, because the closer you are to the wire, the stronger it is. And whenever we're talking about strength of magnetic fields, we measure them in Teslas, which have a capital T for the units. If we now expand this slightly, and rather than having just a single piece of wire passing through card, we turn it into a loop, then what we actually end up with is a design of field lines like the bottom left diagram here. So we still have a couple of concentric circles where the wire passes through the card, but then you can see running down the very center between those 2 bits of wire is a straight line. So just remember that we do have concentric circles just around the wires, straight line down the middle, and then some of the others obviously will just pass off the edge of the bit of card. We're now going to come on to the idea of solenoids. Now, what we're looking at with a solenoid is a coil of wire. And if we've got lots of loops in our coil, we'll make a stronger magnetic field. If we wanted to further increase the strength of our solenoid, then what we can actually do is put a magnetic material, like a piece of iron, into the center of the coil, because as we've already said, once we actually turn on that current in our wire, it's going to generate a magnetic field. A magnetic material is in the magnetic field, and therefore it becomes an induced magnet. So that means we've now got a magnetic field caused by the iron in addition to the one caused by the actual current carrying wire. This gives us the opportunity to create electromagnets. Now, electromagnets are things we can make that are stronger than any permanent magnet at all. And a good example of this is something along the lines of an MRI scanner, for example. So our MRI scanners, those electromagnets, have a 10 Tesla strength. So what we actually find there is that is incredibly strong, and exactly why you don't wear metal into an MRI scanner, because otherwise you won't be wearing the metal in the MRI scanner when they turn it on. It will just be extracted for you. Obviously, if there's bits from today's booster that you'd like to go through in a bit more detail, head on over to the P4 videos on the channel. Alternatively, you can use your revision guide, your classwork notes, and as always, I recommend having a look at least a couple of the previous exam papers, just to give yourselves a bit of a feel for the kind of questions that come up. And then, of course, don't forget to join us once more tomorrow for another Daily Booster.